Hello everybody. So welcome to this refrigeration and air conditioning class. So we have started in the first video. I have discussed about the basic introduction about the refrigerations, right? So here in this video, I will tell the different types of cycles, right? Total refrigeration cycles. Several refrigeration cycles are there. About those refrigeration cycle, I will discuss today. Okay, let me share the screen first. Okay, so today topic is what? Today topic is uh, just 1 minute, guys. Okay, object. Today topic is today topic. I will discuss about okay the refrigeration cycles. Several refrigeration cycles, right? This is my today topic. So what is the classification? A simple classification is there. I will give the simple classification is there. How these refrigeration cycles, what types of refrigeration cycles we are going to study. First, we will study air refrigeration cycle. Air refrigeration cycle. Then we will study vapor compression. Vapor compression. Okay. I'm completely not writing the full words here. Vapor compression cycle. And one next type is uh, vapor absorption, right? Vapor absorption cycle. Absorption cycle. One more category is there. What is that one means? We will study next here. Thermoelectric refrigeration cycle. Thermoelectric electric refrigeration cycle. So these are the several categories. Under air refrigeration cycle, what we are going to study here? Reversed carnot cycle. Reversed carnot. And one more is the Bell-Coleman cycle. Bell-Coleman and several aircraft refrigeration cycle. Aircraft means aeroplane. An aeroplane which cycle is we are following aircraft refrigeration technique. Refrigeration technique. Okay. In vapor compression cycle, in vapor compression, there are again simple vapor compression cycle and compound vapor compression cycle is there, right? Similarly, in vapor absorptions, okay, in vapor absorptions, several types are there. Aqua ammonia NH3. I'm writing here. Okay, lithium bromide and H2O. Okay, lithium bromide water cycle is there. Next, three fluid refrigeration cycle is there. These three, aqua ammonia, lithium bromide, and H2O means water, and three fluid refrigeration cycle. Here in this thermoelectric, okay, we are going to, or this three fluid here, it is also called as electrolux, right? Electrolux. Here we are going to study about this thermoelectric, that is vortex tube type is the vortex tube type. Okay. And here one more is what, uh, thermocouple, by using thermocouple using thermocouple, this thermoelectric refrigeration cycle will be construct, and we will study. So this is the several brief classifications of several refrigeration cycle. Reversed carnot cycle. First I will tell, then this one, then this one. That means first I have to cover this part. This is nothing but your first unit, I think. Air refrigeration cycle, right? Observe, sir. This time, what I am doing, the air refrigeration cycle. Air refrigeration cycle. So why it is called air refrigeration cycle? You know, the refrigeration cycle, actually in the past video I should talk about this one. So cooling effect is produced. What is the purpose of this refrigeration? Purpose is cooling effect, producing the cooling effect, right? For that, producing the cooling effect, what is the one working fluid is required? Working fluid. Okay, working fluid is required. Likely to generate the electric power. Okay, generate the electric power from the in hydraulic power plant or in thermal power plant. The working fluid is required, nothing but steam in thermal power plant, nothing but water in hydraulic power plant. Those are called working fluid. Similarly, in the refrigeration cycle also, to produce the cooling effect, one working fluid is required. What is that working fluid? What we are calling that working fluid? We are calling it is a refrigerant, right? Refrigerant. Okay. So there are some specific refrigerants are available in the atmosphere, in the environment. So the scientists already have done research on that, and they have listed which things can be, or which particular I mean substance can be used as a refrigerant for cooling effect production, but to produce the cooling effect. Not all gases. Okay, oxygen, nitrogen, oxygen, carbon, we cannot use separately those gases, exclusively those gases for cooling effect. Those gases will be used for cooling, for to produce the cooling effect. It should have some specific properties, right? Those properties and those gases are listed by doing several experiment on that. Okay, several experiment on that. That is nothing but called refrigerant, right? Refrigerant. Some example, suppose I will give here. Okay, some example I will give here, which gases are used for uh, refrigerants, right? Which gases will be used as the refrigerant? And there is some code is there, R12. Okay, 1 minute. R12, one refrigerant name. Okay, R22, one refrigerant name. These are several gases. They're given the name by some nomenclatures. This is called some refrigerant nomenclatures. So in the next unit we will just discuss about that. So R22, like this, several refrigerants are there. What is the purpose of the refrigerant? It is act as a working fluid. Okay, without refrigerant, cooling effect is not produced, right? Cooling effect will be not produced. So, sir, where to use this? Where we will use this refrigerant? Inside a machine. That machine is called refrigerator. Okay, refrigerator. The machine is called in the refrigerator. Those refrigerant we will use as the working fluid. Then only cooling effect will be produced. But here, air refrigeration cycle meaning is what? Here the refrigerant, right? Refrigerant is nothing but air. Refrigerant is air. That's why the name is here air refrigeration cycle. Observe. Air refrigeration cycle. So topic is right now air refrigeration cycle. Okay, so why it is called air? Because the working fluid is air. So in this air refrigeration cycle, we are going to discuss about the name, very famous name, that reversed carnot. Leonard Carnot, right? Reverse Carnot cycle. Carnot cycle. Okay. So what is this reversed Carnot cycle? We know a cycle. What is the cycle? So cycle is consisting of several processes. Several processes. When several processes will be togetherly arranged or add, that several processes will constitute one cycle. So here also reversed Carnot cycle means here definitely several processes has been used. Maybe process one, process two, process 3, like this several process has been used to constitute a cycle here, right? So before discussing this one reversed Carnot cycle, let me tell you something about the Carnot cycle first, because opposite of Carnot cycle is a reversed Carnot cycle, right? Opposite of Carnot cycle is the reversed Carnot cycle. Observe, sir. Right? So what is reversed Carnot cycle? Where its applications? Okay. So for which devices this reversed Carnot cycle is discovered? Okay. Who, for which type of devices, which type of machine or engine is there, so that the Carnot derive one cycle and name given Carnot cycle. Where is the use? Really in heat engine, right? In heat engine, the then I can say heat engine in the sense what IC engine, IC engine is a heat engine. Okay, then thermal power plant, right? Gas turbine power plant. All these are working on the concept, the discover of all these are working on the principle of reversed Carnot, sorry, Carnot cycle, not reversed Carnot cycle. Okay, Carnot cycle, principle of Carnot cycles. Actually, not purely on Carnot cycles. When Carnot cycle is modified, then those new cycle is formed. Though on those cycles, these devices are working here. Observe, sir. Simple, I will tell you. So, what is a Carnot cycle? I want to tell you first. What is a Carnot cycle? No, Carnot cycle. So, what the Carnot told? Okay, in Carnot told, in my cycle, in the Carnot cycle, he included 4 processes. What is the process one? Four process. Process one is isothermal process. Process two, which one? Sir, isentropic process. That's why I'm telling the basic of thermodynamics is required. Isentropic process. Process three, again isothermal process. So isothermal. And process four, again isentropic. So he used totally four process. Out of this four process, two are isothermal and two are isentropic. Right? Two are isothermal and two are isentropic. Right? Sir, what is this isothermal? Isothermal compression. Okay. Isentropic expansion, then isothermal expansion, right? Then isentropic compressions. Maybe order changed. Isothermal expansion compressions, isothermal expansion compression. Okay, no problem. We'll see in the diagram. Isothermal compression, isentropic expansion, isothermal expansions. Okay, then isentropic compression. Uh, Like this, four processes. Don't ask, sir, what is isothermal, isentropic, and iso. You need to study the basic of thermodynamics. Isothermal means, sir, isothermal means what? Very simple. Isothermal means temperature is a constant. Isentropic means entropy symbol is S is a constant. Again, temperature is a constant, and again S is constant. This is the several processes symbols, right? So let me draw the diagram first. 1 minute. Delete. Okay, diagram for Carnot cycle, not reversed Carnot cycle, right? Carnot cycle. So to construct this Carnot cycle, let me draw the PV diagram first. Pressure, this is pressure and volume. Pressure, volume, and one more is there. Suppose temperature and entropy, right? So this is entropy S. This is the entropy S, and this is the temperature T. This is volume V, and this is pressure P. So why these two diagram? Because explanation become easy. Easy explanation become easy. So observe 1 to 2 process. 1 to 2 process. Then 2 to 1. Okay. Then 3 to 1 to 2, 2 to 3, 3 to 4. 1 minute, 1 minute. Okay. Then here, very good. This is 1, this is 2, this is 3, and this is 4. Okay. 1 to 2. This is isentropic process. Isentropic. This is isothermal. Isothermal. Again isentropic. Okay, again isothermal. Okay, this is called isothermal compression, isentropic expansion, isothermal. Okay, this is called isothermal expansion, right? Expansion, and this is called isentropic compression. Right? This is the order. How? Let me give the RMR. 1, 2, 2. Choose another color here. Sir, 1, 2, 2. 2, 2, 3. Then 3, 2, 4. 4, 2, 1. The same way in the TS diagram, observe TS diagram. Okay, isentropic 1 to 2 is isentropic. Isentropic means entropy constant. See, entropy constant or not? Yes. Then entropy constant. Okay, okay, leave it. Then isothermal, temperature constant. Again, entropy constant, and again, constant, temperature constant. So what is the name? Simple, same name we give here. So this is 1, 2, 3, 4. This is the order of execution. In this way, the cycle will be moved 1 to 2 process. Okay, now. So here in this diagram, observe. This is about carnot cycle, not reversed carnot cycle, right? T2 equal to T3, and here T1 equal to T4, right? So here I need to find out the efficiency, observe, sir. Right? I need to find out the efficiency. So how to find out the efficiency? Efficiency is what? Eta equal to output by input. Right? Output by input. So here observe output by input. So here I will get the work W. This is W. I'll get W1 to 2. Here heat will be supplied 4 to 1. Q1 to 2. Here heat will be rejected in the condenser Q2 to 3. And here work will be given to the pump W3 to 4. Right? W3 to 4. Okay. Sir, what is the output? Output formula. Sorry, what is the efficiency? Output by input. Observe this diagram, sir. What is the output? W net is the output. W net divided by input is Q1. Input is Q1. Right? Input is Q1. Suppose I will convert this total diagram, to a single diagram, sir. This is Q1 This is my device, and this is Q2, right? So this is Q1 and this is Q2, and here I am getting W net. W net in the sense W1 to 2 minus W3 to 4. Okay, I'm converting this 4 processes diagram, individual processes, instead of I'm going for this diagram. Easy to understand. That's right. Observe, sir. What can I write here, sir? If I'll put the first law, summation of W equal to summation of Q. Okay, so summation of Q means Q1 is there, Q2 is there, and summation of W is W net is there. So Q1 it is supplying to this system. This is the system, machine, engine. So supplying means positive, and it is Q2 is Q2. This is Q2 is rejecting from the machine. So that's why it is minus. So what is the W net value? Q1 minus Q2. Simple. I'll replace this W1. Q1 minus Q2 divided by Q1. If I will simplify this one as 1 minus Q2 by Q1. Okay. 1 minus Q2 by Q1. So there is a beautiful definition relation between, heat and temperature and entropy. What is the relation, sir? ds equal to change in entropy. ds equal to, okay, ds equal to uh, heat transfer, okay, q divided by t. Q divided by t, heat transfer q divided by, then sir q become t into ds or not? Yes, this is the main formula into t into ds, just a cross multiplication I have done. Sir, in this case, in this particular diagram, in this diagram, there is a two hit. One is what? One is Q1 to 2. What is the answer? For Q1 to 2, what is the value? Value become, observe, sir, temperature is what? Q1 to, sorry, uh, 1 to 2, not here. Where it is? I have mistakenly written here. 2 to 3, here 2 to 3 correct. Here 4 to 1, right? This one is 4 to 1 or 1 to 4, not 1 to 2. So Q, this is 4 1, right? Correct. 4 1 or 1 4. Then Q 4 1, 4 1 become, sir, temperature observe. T1 equal to T4. You can write here T1 also or T4 also into ds, right? Into ds. Formula is what? T into ds or not? Into ds. Observe, sir, ds. In this Q41, 41 process, this 41 process, this is the S1 value, S1, and this is S4. S4 equal to S3, and S1 equal to S2. Okay. So now what can I write, sir? Equal to T1 into ds, change in entropy is what? S1 minus S4. Okay, this is equation 1. Now similarly, I find out Q2 to 3. What is the formula becomes? Sir, temperature observed, temperature T2, T3 temperature. Both are equal or not? Yes. Then I can write here T2 into ds, right? T into ds, S2 minus S3. S2 minus S3, right? So what is the Q41 value? Q41 is this much and Q23 is this much. This Q41, this Q41 is nothing but heat input. Heat input. So heat input is nothing but which term we are using for heat input? Q1 here. Q1. Heat input is Q1. So this is the Q1 value equal to Q1, and this one is equal to Q2. Now I will substitute this value Q1, Q2 value in this equation. In this equation I will substitute. Observe sir, what the output I will get here. Okay, what is the formula I have sir? Eta equal to 1 minus Q2 by Q1. And what is the Q2 value? 1 minus T2 S2 minus S3. And what is the Q1 value? T1 S1 minus S uh, S1 minus S4. Okay. This is my diagram. This was my TS diagram, right? This is my TS diagram. Okay. This is 1, 2, 3, 4. So S1 equal to S4, and here S1 equal to S2, and here T2 equal to T3, and here T1 equal to T4. Just last diagram, right? Observe, sir. Observe. Sir, S1, S2 equal to S1, S2 equal to S1, and S3, S3 equal to S4. And what I will do, here S2 is there, S2. In place of S2, can I write S1? Because here S2 equal to S1 or not? This one, this two value is same or not? S2 equal to S1. So in place of S2, I'll replace S1 minus S3 equal to S4 or not? So I'll replace S4. S4. Now see, in the top also is S1 minus S4. The both term will be cancelled. Then what is the remaining? 1 minus T2 by T1. Okay, 1 minus T2 by T1 eta efficiency of reversed carnot. Sorry, carnot cycle only, not reversed carnot cycle. Right? This way we are going to find out. In the same way, observe. Same way, just a direction will be changed in the reversed carnot cycle. Okay, in the reversed carnot cycle. What is the order 1 to 2, 2 to 3, 3 to 4? Now in this case, reversed carnot cycle, that order will be totally reversed. If there is clockwise, then it become anti-clockwise. If there is anti-clockwise, it become clockwise. Reversed carnot cycle. Okay. So here also same four processes, two isothermal and two isentropic. Later I will tell what is the disadvantages of this one. But for two isothermal and two isentropic process. Observe, sir, I am arranging the cycles here. This is PV. Okay. This is PV and this is same diagram, exactly ditto, same diagram, only arrow mark direction will be changed. And this is the okay. This is pencil bronze. This is S, this is T, V, and P. What is the diagram here? Like this. Like this. Okay. Now, in the previous case, here was 1, 2, right? Now reverse it. This is 1, this is 2, this is 3, and this is 4. The same here also. Slightly corp lines is the straight line. So 1, 2, 3, 4. Right? 1, 2, 3. Reverse carnot side. So what are these? What are those processes? This is isentropic. This is isothermal. Again, this is isentropic. And this is iso. Right? Same. In the previous case, heat was supplying, but a refrigerator means heat has to be extracted. This is the inside of the refrigerator. This part is the inside of the refrigerator. Right? This is the inside of the refrigerator. Okay. So, this is called uh, Q1. Here is what Q1, and heat is rejected to outside Q2, and work is supplied W. Work is supplied W. Right? W. Then, sir, in this particular case, what is the efficiency? I told in the previous video. I told if here efficiency term is not suitable. Which term will be suitable? COP in case of refrigerator heat pump. Which term will be suitable, sir? COP. Efficiency meaning is output by input. COP meaning also output by input. See which one is the output? Which one is the requirement? That is our output. Here requirement is heat, how much cooling, Q1, how much it, and W. Okay, Q1 into W. Okay, so now if I convert into the single diagram, single block, this is the machine and this is the diagram. So what will happen? W is given here, Q2, and here Q1. Can I write applying first law? Applying first law. Q1 is there, Q2 is there, and W is there. Summation of heat equal to summation of work. Now Q1 is a, see, observe, Q1 enter into the system, that means plus, and Q2 exit from the system, that is minus. Okay, Q1 minus Q2 equal to W. Now in this equation I will put, in this equation I will put Q1 divided by W in place of W, Q1 minus Q2. Right? Now, just before I told the entropy temperature relation, entropy temperature and the relation in the Carnot cycle. What is the Q1 will become here? Q1. So Q1 nothing but Q1 is nothing but here. But T1 into S1 minus S4, and Q2 is nothing but Q2 T2 into uh, T2 into S2 minus S3. Okay, S2 minus S3 or S3 minus S2, based on this sign you have to check. Next, I have to put these values in this equation. In this equation I need to put. If I will put, observe, if I will put, what answer I will get? Hmm. Hmm. If I will put eta equal to Q1 divided by Q1 minus Q2. Q1 divided by 1 minute. Okay, eta equal to formula was output by input. So output was Q1, input was Q2 minus Q, right? W rate is equal to Q2 minus Q. So what is the Q1 value? Just T1 into T1 into S1 minus S4, and Q2 value is T2 into S2 minus S3, and Q1 again T1 into S1 minus S4. Now, what I told in the diagram, the pivot diagram, TS diagram, okay, TS diagram, S1 equal to S3 and S2 equal to S4, right? S2 equal to S4. Observe S2, S2 equal to okay, S2 equal here. Here I think S2 equal to S4. Okay, here you change it, right? S3 minus S2. No problem. S3 minus S2. Now, in place of S3, can I put S1? And in place of S2, can I put S4? Now, this term you delete, this term you write. Right? Because same, both same. So, S1, S4, I will take common is equal to T1 divided by S1 minus S4 common. Then remaining is what? T2 minus T1. Here also top S1 minus S4 is there. So both will be cancelled here. What is the output I'll get? T1 by T2 minus T1. This is the COP of T1 by T2 minus T1 reversed carnot cycle. Okay, reversed carnot cycle. So I'll conclude here. The next video I will discuss what is the limitations of this one, and what if I'll change these parameters, right? T1 value if I'll change, T2 value if I'll change, then what will happen to the COP? That things also I will discuss in the next video, sir. I'll conclude here. Please take care. Bye.